Okay, so these questions are all about efficiency, and for efficiency we're going to be using the equation that efficiency equals the useful output energy divided by the total input energy. Sometimes they might give you a question with a Sankey diagram like so, but we're still going to be using this equation to work out our efficiency. So the first thing we need to do is identify which of the outputs is the useful. In this case, pretty simple because they've labelled it as useful, but we also need to know the size. So to do this, we're going to count the squares. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So that we know our useful output energy is 10. We need to divide that by our total input energy. Again, we need to count the squares, and if we count the squares along here, we can see that we've got 10 over 25. If we work this out, then 10 over 25 gives us 0.4, and then to turn it into a percentage, we need to times it by 100%, which gives us 40%. For this example for efficiency, it doesn't matter about the units. In question 2, it tells us about the aircraft solar cells, and it gives us the input energy, which is 175,000. And it tells us that the useful energy that's transferred is 35,000. So that goes along the top. And again, to work out our percentage efficiency, we want to times it by 100. Calculating this gives us an efficiency of 20%. Finally, for our last example here, it's giving us the useful energy and the wasted energy, however we haven't given us a numerical value. However, due to the law of conservation of energy, we know that whatever comes in must come out. So 30 joules over here of waste energy, plus our missing value, which I'll say is X, will give us the total input, which is 120 joules. Rearranging this, we can see that 120 minus 30 equals X, and therefore X equals 90 joules. We can now put these numbers back into the equation. So the useful output energy was 90, divided by the total input energy, which was 120, gives us 0.75. Timesing it by 100% gives us an efficiency of 75%. So if you're confident with these first two that you can use the equation, and if you're confident using the diagrams with the Sankey, fill in over here.